Hey everyone, and welcome to This Explainer. Today, we are literally deconstructing the anatomy of a millisecond. Listen, if you're involved in modern financial infrastructure, you already know the landscape is shifting at absolutely breakneck speed. So what we're going to do today is build a comprehensive, layer-by-layer architectural blueprint for a highly available cross-border payment processing system that is fully equipped to handle the rigorous demands of 2026.
Let's start with the high-stakes scenario that, well, has probably made all of us sweat at some point. What actually happens when your payment system goes offline right in the middle of a massive rush? Sure, a local mom-and-pop shop might just pivot to cash, but for an enterprise system, going offline means bleeding millions in lost revenue. Actually, scratch that. It can be thousands of dollars a second. And honestly, worse than the immediate financial hit, it completely shatters customer trust. Uptime and absolute precision, they are simply non-negotiable for survival today.
Okay, let's dive into this. Here is our architectural blueprint for the day. First, we'll lay the foundation. Then, orchestrating the core engine. Third, we'll look at multi-currency ledgers. Fourth, programmable money. And finally, global compliance.
All right, part one, the foundation, data, money, and risk. And this brilliantly illustrates a critical point. Every payment system out there, no matter how insanely complex it gets under the hood, is basically divided into core layers, like data, money, and risk. This decoupling of timelines is absolutely crucial. See, your data layer handles real-time communication, like authorization, in just seconds, which is what allows a customer to grab their coffee and walk out the door. But the money layer? That governs the actual clearing and settlement between institutions, and it operates on a heavily delayed timeline, often taking days to actually finalize.
Because of these very different timelines, we absolutely must separate specific roles across our architecture. Your gateway securely captures the data, the processor routes it, the acquirer actually settles the funds, and the issuer makes the final call to approve or decline. Now, I have to warn you right here, confusing a gateway, which just transmits the data, with an acquirer, which manages the financial settlement, will lead to massive systemic design flaws. You have to know exactly who does what.
Moving on to part two, orchestrating the core engine. We're building a unified routing engine.
If you've ever pulled your hair out over mysterious drops in authorization rates or agonizing integration projects, you know you need an orchestrator. To process thousands of these routed transactions concurrently, our 2026 system desperately needs a robust central nervous system, and Apache Kafka acts as exactly that. It's a lightning-fast, event-driven spine. It loosely couples your architecture, which effectively decouples producers, like your payment gateways, from consumers, like your fraud detection modules. So if your notification service suddenly crashes, no big deal. Your payment gateway just keeps humming right along independently.
Now, if Kafka is our internal nervous system, ISO 20200 is our universal translator for the outside world. It standardizes global banking communication. But there is a massive catch here. You must ensure your microservices speak the exact same dialect. You have to be able to differentiate between a pain.08, which is pushing money out, and a pain.013, which is pulling funds in. Getting these dialects wrong at the routing level doesn't just cause a minor bug, it literally breaks your entire clearing process.
So the crucial point is maintaining absolute correctness at infinite scale, especially during those inevitable network timeouts. We achieve this through strict idempotency. Here's how it flows. First, we extract the unique key from the incoming request. Second, we rapidly query an Elasticsearch cluster. Third, if we've seen that key before, we just safely return the cached success response. And fourth, only if it is genuinely new do we process and store it. This sequential pipeline is what prevents fatal duplicate charges and maintains total ACID compliance.
Okay, part three, multi-currency ledger mechanics. This is our highly capable operational layer for cross-border money movement. Listen. If you are building a cross-border system in 2026, an abstract single balance table is completely useless. Enter the multi-currency ledger. To be crystal clear, this is not just some conversion layer that translates a USD balance into ER just to look pretty on a display screen. No, it is a core operational system using double-entry bookkeeping where USD and ER have completely independent life cycles. They are distinct balance states.
A properly built multi-currency ledger tracks wallet balances, internal transfers, and payout states with absolute precision. By modeling cross-currency movements with explicit foreign exchange fee entries rather than opaque net updates, you completely prevent those nightmare balance inconsistencies where one side of a transaction succeeds while the other fails.
It makes complex reconciliation totally tractable for your finance teams. They'll thank you for it, for sure.
Let's shift gears to part 4, the programmable money shift. This is the next generation infrastructure.
We are currently witnessing a monumental shift where value and data are actively merging via programmable infrastructure. A prime example of this, Project Agora. It's a massive, groundbreaking collaboration led by the Bank for International Settlements. They've essentially brought together 7 major central banks and a group of private sector companies to test a multi-currency unified ledger specifically designed for wholesale cross-border payments.
Now, what's really interesting about this is that Project Agora isn't trying to rip and replace the entire global financial system. Rather, it's a prototype designed to dramatically improve the existing correspondent banking model. By bringing tokenized commercial bank deposits and safe central bank settlement assets together onto a single programmable platform, it utilizes smart contracts to execute atomic, instantaneous cross-border transactions.
And right alongside those central bank initiatives, we have stablecoins like USDC and EURC. These are digital currencies pegged to reserve assets that support 24/7 programmable settlement. They are an incredibly powerful tool for real-time value transfer, largely because they operate entirely without regional barriers or the need for heavy pre-funding in local, fragmented accounts. Because of all this programmability, traditional roles in finance are completely shifting. Virtual asset service providers, payment service providers, and traditional banks are all transforming into programmable endpoints. Verification, compliance rules, and reporting, that all happens dynamically within the transaction flow itself now. This completely reinvents institutional responsibilities, finally moving us away from slow, batch-processed verification.
Which brings us to our final piece, Part 5, Scaling Global AI Compliance.
With programmable instant money comes the ultimate macro-level challenge, compliance. We are seeing intense regulatory divergence right now. Enterprises have to continuously reconcile overlapping rules driven by regulatory localization, sudden post-election rule changes, geopolitical tensions, and the strict enforcement of the EU AI Act kicking in by August 2026. This means an enterprise has to balance distinct and sometimes totally conflicting obligations across the US, the EU, the UK, and Asia-Pacific all at the exact same time.
Let's move on and see how this builds. Because of this extreme fragmentation, technology is the only practical way to handle compliance automation. Manual fraud monitoring, which is retrospective, rules-heavy, and very limited, is being entirely replaced by AI-driven monitoring that streams in real time, adapts on the fly to lower false positives, and scales infinitely across global channels. To govern these incredibly powerful AI systems across borders, researchers are proposing blockchain-enabled frameworks. These utilize distributed ledgers to create a decentralized, borderless AI governance ecosystem. This ensures that the AI systems themselves remain secure, transparent, and compliant, completely regardless of jurisdiction. At the absolute heart of this framework is the decentralized identity, or DID. By assigning a unique, tamper-proof cryptographic ID to high-risk financial AI models on a permissioned blockchain, we ensure total accountability. If a regulatory update occurs, the DID is automatically updated right along with it, creating an immutable audit trail that regulators from literally any country can continuously verify. We then enforce this with smart contract compliance. It's a fascinating flow. The system ingests real-time data, runs natural language processing algorithms to read regulatory changes, executes automated conformity assessments, and finally, updates the blockchain. These self-executing agreements can automatically verify complex loan agreements or algorithmic trades against strict regulations like Basel III, all without manual oversight.
And that brings us to the ultimate crossroads of our 2026 architecture. We've built the foundation, we've orchestrated the Kafka engine, deployed multi-currency ledgers, and automated global compliance to make money move seamlessly at the exact speed of data. The technology is here, and frankly, it is brilliant. But it leaves us with one provocative question. We have the tech to make money move at the speed of data, but is the traditional global banking system truly ready to relinquish its legacy control to the code? Thanks for joining me on this explainer, and keep building the future.